first of all this shear force equation to obtain the shear force diagram. Now look at the beam. The beam we have has uniform distributed load up to 2 meter of the distance. From 2 meter to the 4 meter there is no load acting on the beam, but at 4 meter, that's at its free end, we are having a load of 2 kilonewton. So what we do, so this equation, from this equation what we have, so when we substitute the value of x is equal to 0, v comes out equal to plus 5. So at x is equal to 0, our v is equal plus 5. This is the value of shear force at the fixed end. Now this equation, the value of at x is equal to 2, so this is 1.5 into 2 is 3, so this is 5 minus 3 is equal to 2. So at x is equal to 2, the value of the shear force, that is x is equal to 2, 1.5 into 2 is 3, 5 minus 3 is 2. So the value of the shear force at x is equal to 2 is equal to how much? It's equal to 2. So this is the value of the shear force at x is equal to 2. Now this is the straight line whose slope is negative. So this is the shear force decreases when you move from x is equal to 0 to x is equal to 2. So this is the shear force line or shear force diagram for x is equal to 0 to x is equal to 2. It's essentially a straight line with sloping downwards. Now see here, if you are going from x is equal to 2 to x is equal to 4, there is no load acting on the beam. We have already derived the equations, that is dv by dx, the gradient of the shear force, is equal to the W. W is the intensity of the distributed load acting on the beam. Now from x is equal to 2 to x is equal to 4, in this very region we don't have any load acting on it. Therefore the value of W in this very region, the value of W in this region is equal to 0. Now when dV by dx is equal to 0, it means the V is isolated constant. That is, the value of the V remains constant from x is equal to 2 to x is equal to 4, and that value is here. So from x is equal to 2 to x is equal to 4, the value of the shear force remains constant. Therefore the line from x is equal to 2 to x is equal to 4 is a straight line. This is the shear force diagram for this beam. Okay, so what's very important is understand this equation, dV by dx is equal to W, where W is the intensity of the distributed load. Now from x is equal to 2 to x is equal to 4, in this region there is no load acting on the beam. Therefore the value of W in this region is 0. When the value of W is equal to 0, then it means V is isolated constant. Its value is constant in the region. So whatever is the value of the V at x is equal to 2, the same will be the value of the V at x is equal to 4. Therefore it becomes a straight line. Therefore this is the shear force diagram for this type of beam.